Let's start with the basic idea. The sum of two cubes, represented by a cubed plus b cubed, and the difference of two cubes, represented by a cubed minus b cubed, are two very important algebraic identities that help us factorize cubic expressions. The sum of cubes formula is a cubed plus b cubed equals a plus b times a squared minus a times b plus b squared. Similarly, the difference of cubes formula is a cubed minus b cubed equals a minus b times a squared plus a times b plus b squared. These identities allow us to break down seemingly complex cubic expressions into simpler factors. Let's now focus on how we arrive at these formulas. First, let's look at the sum of cubes, a cubed plus b cubed. By using algebraic expansion and simplification, we find that the sum of cubes can be factored into a plus b times a squared minus a times b plus b squared. This is not just a random result, it follows from how cubes of terms behave when expanded. The first factor, a plus b, represents the sum of the terms. And the second factor, a squared minus a times b plus b squared, balances out the powers of a and b to maintain equality. This identity simplifies cubic expressions and is very useful in solving algebraic problems. Now, let's explore the difference of cubes, a cubed minus b cubed. Again, we can factorize it using a similar process. The difference of cubes can be written as a minus b times a squared plus a times b plus b squared. Here, the first factor, a minus b, accounts for the difference between the two terms. The second factor, a squared plus a times b plus b squared, is the expanded form that makes the equation true. Just like the sum of cubes, the difference of cubes follows an algebraic pattern that simplifies these cubic expressions. Let's look at a practical example. Suppose we have the expression x cubed plus 8. Notice that 8 is the cube of 2, so we can rewrite the expression as x cubed plus 2 cubed. Using the sum of cubes formula, we get x cubed plus 2 cubed equals x plus 2 times x squared minus 2x plus 4. This simplifies the expression into two factors, which can now be used to solve equations or simplify further algebraic operations. By recognizing the sum of cubes, we can break down the expression in a much more manageable way. Let's try a similar example for the difference of cubes. Consider 27x cubed minus 125. Notice that 27x cubed is the cube of 3x and 125 is the cube of 5. So we can rewrite the expression as 3x cubed minus 5 cubed. Now, using the difference of cubes formula, 3x cubed minus 5 cubed equals 3x minus 5 times 3x squared plus 3x times 5 plus 5 squared. Simplifying the right side, 3x minus 5 times 9x squared plus 15x plus 25. This shows how we can easily factor cubic differences using the formula, making complex expressions much easier to handle. Let's quickly revise what we've learned today. The sum of cubes formula is a cubed plus b cubed equals a plus b times a squared minus a times b plus b squared. The difference of cubes formula is a cubed minus b cubed equals a minus b times a squared plus a times b plus b squared. Both of these identities help us factor cubic expressions and simplify algebraic calculations. Now, whenever you come across expressions like a cubed plus b cubed or a cubed minus b cubed, you'll know exactly how to factorize them into simpler terms. I hope now you understand how these formulas work and how they make solving cubic equations much easier. In the next video, we will explore more algebraic identities and their applications. See you then.